Hello friends, this is Yogesh Muramkar. Today we are going to talk about aggregation framework and the indexing, the uses and advantages of indexing. So let's start with the same. So we have a document, and in that document I have mentioned about aggregation framework and indexing. So we are going to talk about this particular statement. We are going to implement the aggregation and indexing with suitable example in MongoDB, and we are going to demonstrate this aggregation framework, and at the end we are going to create and drop different types of indexes and explain the advantages of indexes. So for doing the same, let's open the terminal and connect to MongoDB. So we have already installed MongoDB on this particular Ubuntu machine. So currently I am in this path, so I will go to downloads folder. In downloads folder I have MongoDB folder, so I will go to that. So this is just a process to connect to the MongoDB which we have installed manually. Then I will go to bin folder. In bin folder I have these many number of binary files. Okay, so what I am going to do is I am going to set my database path. So for that, in the current folder I will use this particular binary file MongoDB hyphen db path. Okay. And then the path is this, and in this I have created data folder. So I am going to run this particular thing in the background. So it is going to wait, which we have already seen, it is going to wait on 27017. So what I will do, I will open new terminal with Control Shift N, and then I will start Mongo. So in the current folder Mongo. So this is how I have connected to the Mongo shell. So I am using a default database. So let's open the document. Now aggregation framework. So let's start with the aggregation framework. Now aggregation operations process data records and return computed results. Aggregation operations group values from multiple documents together and can perform a variety of operations on the grouped data to return a single result. MongoDB provides three ways to perform aggregation. First one is aggregation pipeline, second one is the map reduce function, which we have already seen in the previous video, and the last one is single purpose aggregation method. So to understand what is aggregation framework and aggregation, let's see this example. Now this is the collection, orders collection we have created. So in orders collection we have 4 documents, 1 2 3 4. So let's create orders collection first as shown in the diagram. So this is we have created in the previous video. So what I will do is I will just copy this particular code to create the orders collection. See, this is what I am creating, orders collection. So I will just copy it. That's it. And then so I have created a orders collection. If I want to see what is there in orders collection, so you can see it by using find db dot orders dot find. So what we have in orders collection is these 4 documents with customer ID A123, customer ID A123, customer ID B212, and then again customer ID A123, and then respective amounts and status. So we have created this particular orders collection according to the diagram given in this particular document. Now we want to apply the aggregation framework. Now aggregation framework is nothing but it is exactly similar to what we have seen in SQL, that is group by clause. It has these 2 stages. First is the match stage. So what I am doing is I have 4 documents. So first condition is I am going to match the condition, and my condition is the status should be A. So out of these 4 documents, in 3 documents I have stated as A. So that's why I got, after matching condition, I got 3 documents. Okay, and then in group stage what I am doing is I am calculating the sum of the amount and grouping that sum of the amount according to customer ID. So according to customer ID, A123, A123. So total amount, sum of the amount will be 500 plus 200, that is 750. And here I should get for B212 the sum of the amount, that is total, should be 200 only. So that's what I will get after executing this particular statement in MongoDB. So I am going to copy the same thing. So this same thing is shown here in this particular statement. So I am just going to copy it and run it in the Mongo shell. So go to the Mongo shell. So what I should get is the final result which is shown in the diagram. So see, for ID B212 the total is 200, and for ID A123 the total is 750, that is 500 plus 250. So this is a simple example to explain aggregation framework. So it has 2 stages, match stage and group stage. So it is only a 2-step process. Just create the document and create the collection with these documents, and use matching stage and group stage, and finally use the aggregate function to do this. Okay, now another example we will see for aggregation framework only. Now aggregation operation process data records and return computed results. Aggregation operations group values from multiple documents together and can perform a variety of operations on group data to return a single result. In SQL, count star and with group by is an equivalent of MongoDB aggregation. So that's what we have discussed earlier. So it is just exactly similar to what we have learned in group by clause. Now for the aggregation in MongoDB, we should use aggregate method, which we have seen earlier. Now the next example is what? We are going to create a collection named as tutorials, so which is having 3 documents. The first document with ID1, second document with ID2, and the third document with ID3. So what I will do is I will just copy it and then run it in Mongo shell. So I am going to create a tutorials collection with 3 documents now. So name of the collection is tutorials. Just copy it. So if I want to see, so db.tutorials.find. So it has created tutorials collection with these documents. Okay, after that what I want to do on that particular tutorials collection is I want to display list that how many tutorials are written by each user. Okay, so that's why we will use aggregate function here. So see, what are the fields shown here? The first field is ID, the next field is title, the next field is description, and then the next field is by user, another field is the URL, and another field is tags. So same is for the second document, ID2, title is NoSQL overview, description is this, and the what is the username? The username is Yogesh. Okay, so like this third document is also there with ID3. So I want to do what? I want to display list that how many tutorials are written by each user. So I want to count number of tutorials by each user. So according to me there are 2 users only, Sachin, and another user is Yogesh. So here Yogesh user has written actually 2 tutorials and Sachin has written 1. So that's what our output will be at the end after executing this particular aggregate function. So I will just run this thing. So what I am going to do is I am going to actually do this thing in SQL. This is what I am going to do in MongoDB. So select by underscore user comma count of star from my collection. My collection is what? Tutorials, and I'm going to group it by user. Okay, so just copy it. So finally we should get for Sachin tutorials is 1, and we should get for Yogesh user the tutorial number of tutorials is 2. So just run it. We have already created the tutorials collection. I am going to run aggregate function on that. So db.tutorials.aggregate, I am going to find out number of tutorials and calculate their sum, and I am going to group it by user. Okay, so see, uh, the user Yogesh has number of tutorials as 2 and user Sachin has number of tutorials as 1. So that's it about aggregation framework. Now the next part is, so here you can refer to this document and some details are given in this particular document, so you can just read it. But for aggregation framework, that is sufficient. That is just a concept which is exactly similar to what we have learned in case of group by clause. Okay. And this you can refer. So these are the different keywords which you can use. Out of this we have used match keyword for matching the condition, and then for group by we have used group keyword. Okay, now we will move to the next part, that is indexes. Now why to create the indexes? The basic purpose of creating the indexes is to optimize our search. Okay, why to optimize the search? We need to optimize the search because it takes sometimes it takes more time to get the required results. What I will do, I will create a sample collection. I will create this collection, YPM collection, and what I am going in this particular thing is I am inserting uh, these many number of records. Okay, so what I will do is I will increase this number also. I will make it to 1 crore records. So what I will do, I will copy this particular statement. This statement is doing is what? It is inserting these many number of documents into YPM collection. So just copy it and create a YPM collection. So I will just increase this number. Okay, okay, it is what okay, here we are actually creating inserting 1 lakh records in YPM collection. So let it be. So okay, that's why it will take some time, as the number is greater. It will take some time to insert those many number of records in this collection, this YPM collection. Okay, so for variable I equal to 1, I less than or equal to 1 lakh, I plus plus, so it is going to insert 1 lakh records in YPM collection. That's why it is taking some time. So let's wait for it to get it inserted, and then we will do the next part for indexes. So approximately I think it will take less than 1 minute only. So we are inserting the student ID and the name of the student. So these many number of records are inserted. Now if I want to see those records, so we can see by using db dot the collection name dot find. So actually we have inserted 1 lakh records, so it is not possible to see 1 lakh records at a time. So at the most it will display us 20 records, but if you want to see the next 20, we can type it, that is iterate. It stands for iterating. Then again we can type it. So like this we can see the remaining records. So we have a document called we have a collection named as YPM with 1 lakh records. Now we will see this one also. Show DBS will show you what are the databases available. So we have admin, local, and test. By default the database used is test database. Now it will also show us, show collections will show us what are the collections available. So these are the collections which are currently available. And this is what we have just now done. If you want to see what is there in YPM collection, so you can see it like this also. Okay, So there are 1 lakh records in YPM collection. Now I will execute this particular command. What I am going to do is I am going to find out the record with student ID 5. So just run it. So what is actually happening? I am actually using find here. So what is the difference between find and FindOne is, if I want to find out some record or some document from a collection, find is going to search in the whole collection for that particular document, for that matching condition. But in case of FindOne, if FindOne finds the first record, it will stop there only. So that is the difference between find and FindOne. That's why FindOne is faster as compared to find. Now db.ypm.findOne. So actually FindOne takes less time as compared to find. Because why? Because find is going to go through all the documents into that particular collection, from that particular connection. But FindOne, what it does, if it finds the first document according to the matching condition, it is going to stop there only. So that's why FindOne is faster as compared to find. And by default, if we create any collection, by default there will be an index created with underscore ID for every document. So this is also the find command we are going to use, but we don't have this many number of documents actually. So what I am going to do is I am going to make it to 50,000, because total we have 1 lakh only. So if I want to find 50,000 document, 50,000 student ID, so I will run find. So it might take some time if there are no indexes created, but if there are indexes created manually, then it is going to show you the result within no time. That's what indexes do. That is the purpose of indexing. Indexing is actually used to optimize the search, to make our search faster. Okay, so here we have talked about the difference between find and FindOne, which I have told you. Okay, now we will see how to create the indexes. So collections we have seen, what are the collections available. Now I will check what are the indexes available. So db.system.indexes find, there is no index actually, that's why it will not show any index. We have not created any index, that's why. Now how to create the index? One method to create the index is like this: db.ypm, that is collection name, dot ensure index student underscore id 1. So on this particular field we are creating index. So this is one method to create the index. So this is how it has created the index. And now, but it is not a system index. Again, it will not show us any result, this db.system.indexes, because there is no system index which is available. Now same explanation is given here. If we created index on student ID, it takes little time to create the index, as we have in our case we have 1 lakh records instead of IPM collection. After creating index on student ID, what we will do, we will run the same command by using find. So it is going to take, so it will take less time, as we have index already created. So it was our 50,000. Now ideally it should take less time to find out the student ID, because we have index created already. So that's what the use of indexes, to optimize the search. So again there is one more command in MongoDB to find out the last document. So I will make it 1 lakh. So as we have indexes created, it will take less time. Now how to drop the indexes? So to drop the index, we have this command db.ypm.drop indexes. This is the command, and I want to see what are the indexes, so you can use get indexes. So just copy it and run it. Anyway, we are going to see the indexes by using a separate document. So these are the indexes we have created, and if I want to drop it, so just run this. db dot ypm dot drop indexes. So it has dropped the index. Now if I run get indexes again, so it has drop indexes. Index was 2, non-add index dropped for collection. So it has dropped that particular index, okay, by using db.ypm.drop indexes. Earlier it was showing us this thing with get indexes. Now it is showing us this particular thing, okay. So it has dropped this particular index. Now we will talk about indexes in other document. So indexes in MongoDB. So MongoDB creates a unique index on underscore id field during creation of collection. Okay, so we already talked about this. The underscore id index prevents clients from inserting two documents with same value for underscore id field. That is, there should not be any duplication. Okay, you cannot drop this index on the underscore id field. So the index which is created while creating a collection, that particular index cannot be dropped, which is on underscore id field. Now these are the types of indexes: simple index and compound index. So we will create these indexes. So to create the index, what is the syntax? db.collection.create index, and then keys, and then options. So in the previous document we have already seen how to create the index by using ensure index. So just create a non-unique simple index for users collection on age field. So to do this, what I will do, I will just copy this particular command, db.users.create index on age field, and I want this index to be non-unique simple index. So that's why I am writing false in front of the keyword unique. So just copy it, just paste it. Okay, it is showing error message. Okay, the spelling of unique is wrong. It should be UNIQUE. Now it will create the index. Yeah, it has created the index which is non-unique simple. So now we will create another index on users collection by using this particular command. So create a unique simple index for users collection on user id field to prevent duplicate names. So this is also simple index, but it is unique simple index. So that's why we have written true in front of the keyword unique. So see, db.users.create index, first name, last name, unique true, and the name of the index is this compound index, first name, last name. So this is what we have created, a unique simple index. So it was created on users collection on user id field. Okay, and then how to view the indexes created for collection. So to view the indexes, you can view it by using these three ways: get indexes, get index keys, get index specs, that is specifications. So syntaxes are db.collection name dot get indexes, db.collection name dot get index keys, db.collection name dot get index specifications. So first we will see what are the indexes on users collection. So db.users.get indexes. This is to view the indexes of users collection. So it is showing the details of the indexes on users collection. Next one is list out the index keys of user collection. So if I want to list out the index keys, so db.users.get index keys, this is the command. So it will show me the index keys for users collection like this. And then finally how to drop the indexes. So to drop the indexes, the syntax is db.collection name dot drop index and index name, or db.collection name dot drop indexes. So whether you can run. So what we will do, we will drop the index created earlier on age field on users collection. So just copy this and we will try to drop it. So number of indexes was 3. Now this index is dropped. Or we can do it like this, db.users.drop index age 1. So we already dropped it actually, so that's why it is showing index not found, because we already dropped it. Okay, so either you can use the first this particular method, or you can use this particular method. Now I want to drop all indexes on users collection, so I will use db.users.drop indexes. Just copy it. So db.users.drop indexes, it will drop all the indexes. So number of indexes was 2. Message non-id index dropped for collection, non-underscore id, because I already told you the indexes which are created while creating a collection cannot be dropped, that is underscore id indexes cannot be dropped. So if I try to run get indexes, so it will show me only underscore id index, it will not show me the indexes created on users. So that's it friends for aggregation framework and indexing. Thank you.